Math Blast Week 18, Adding and Subtracting Fractions. Find the sum or difference. Show all work using math or models. 8 2/5 minus 3. Here we're finding the difference, the answer to the subtraction problem. When I'm subtracting, I want to subtract like units. So I'm going to show this problem in a vertical form, 8 2/5 minus 3. Now the 3 needs to be taken from the 8 wholes because those are like units. So I have my problem lined up in a vertical form here, and I'm going to start with the smallest units, the fractional parts. So I have 2/5 minus nothing is 2/5. 8 wholes minus 3 wholes is 5 wholes. 5 2/5 is the difference, the answer to my subtraction problem. 2 5/8 plus 4 1/2. Here I'm finding the sum, the answer to an addition problem. Again, I'm going to line up my units here. I want my wholes added to my wholes, and then I want the fractional parts, 5/8 added to 1/2. We're going to start with the fractional parts, the 5/8 and the 1/2, and notice those are not like units. So we're going to work to make those like units. I want to model 5/8. So in my area model here, I'm going to model 5/8. I want to break the whole into eighths. So as best as I can, I'll make 8 equal parts. And now I want to shade in 5 of those 8 equal parts. And I've modeled 5/8. Now, I'm going to, in a bottom area model here, I want to model 1/2. So I'm going to break the whole into halves. And this time I'm going to draw my lines in a horizontal form. So here I have 1/2 when I shade in one of those 2 parts. Now, in order to make like units, we're going to transpose the lines on each of the models. So the horizontal line that I drew on the bottom model is going to be put onto the top model. And the lines that I drew in the top model are going to be put onto the bottom model. And now we can see that we have like units. There are 1/16 in both models. So our 5/8 actually became 10/16, and our 1/2 actually became 8/16. Now we don't want to forget the whole number part that we have, the 2 and the 4, so I'm going to go ahead and I'm going to bring those over as well. And now adding the like units, the 16ths, 10/16 plus 8/16 gives me 18/16. Now if I were to take, let's say 6 of these 16ths and put them up here into this model, that whole model would be filled. And so I would have a whole, one whole, and I would be left with 2/16 right here. So 1 whole and 2/16. Now, when I look at my whole, I have 2 and 4 that I'm adding together. So I would have 6. So let's put this 6 and this 1 whole together, and I end up with 7, and I have 2/16 as the fractional part. So the answer, the sum, is 7 2/16. Fraction, addition, and subtraction word problems. Sammy had a sticker collection. In her collection, 1/5 of the stickers were animals, 1/3 of the stickers were smiley faces, 2/5 of the stickers were scented, and the rest had words on them. What fraction of the stickers had words on them? Okay, so we're going to start out here with knowing that we're adding these parts together. In her collection, and her collection is one whole collection, and that whole collection is equal to 1/5 with animals, 1/3 with smiley faces, 2/5 as being scented, and we're not sure how many had words, so we're going to call that W. And now I want to put these together. I'm going to put my parts together and know that I have to be able to add up like units though, right? So my thirds and my fifths don't work quite well together yet. If I were to model a fifth, I'm going to take my whole and I'm going to break it into 5 parts, and I'm going to shade in one of those 5. And for my third, I'm going to take a whole and I'm going to break it into thirds. Oh, and this time I'm going to actually make my lines go in a horizontal direction. And now I'm going to shade in one of those thirds. And my 2/5 I could go ahead and add into my 1/5 here. So I'm going to show that this green 2/5 I'm just going to go ahead and add into here. So this is 3/5. When I put these two together, I have 3/5 and I'm adding 1/3 to that. Now I want to make those like units, so I'm going to transpose the lines. The 2 horizontal lines that were in my second model I'm going to put into the first model, and the vertical lines that were in my first model I'm going to put into my second model. And now we can see that we have 15ths, and 3/15 became 9/15, and 1/3 became 5/15. And so when I add those together, I get 14/15. So we know that all of this is 14/15. So 1 is equal to 14/15 plus W. Well, if I take my 1 whole, which is 15/15, and I know that I already have 14/15 accounted for, then W has to equal 1/15. So I can state that the stickers that had words on them would be 1/15 of the collection. Order of operations: 75 minus 32 divided by 2 plus 6 in parentheses times 3 plus 17. Order of operations, I need to do, there's this PEMDAS idea, right? I want to do everything that has parentheses first. So 2 plus 6 is 8. I'm going to drop everything else that hasn't been used down so I don't get lost in my work. And now I want to do any exponents. There are no exponents in my work here. So next I'm going to do multiplication and division together from left to right. So here I have division. There's 4. And I'm going to drop everything else that hasn't been accounted for down. I'm still on multiplication and division because here's 12. Again, drop everything else down. Anything that hasn't been underlined drops down. And now there's no more multiplication and division. So now I'm going to do addition and subtraction together from left to right. 75 minus 12 is 63. That was that part. I still have to add 17. And then 63 plus 17 is going to be 80. And so 80 is the simplification of that expression. For B, same idea here. We're going to go through and do any parentheses first. So 1 plus 7 is 8. Anything that hasn't been underlined needs to drop down. Next, I have exponents. There are no exponents in my work, so I move on to the next step, which is multiplication and division together from left to right. So 15 times 5 is 75. I'll drop everything down that hasn't been underlined. And I still have a multiplication and division part here, so I'm going to do that. Drop everything else down. Again, there's another multiplication and division part. Drop everything else down. And now we're moved on to the addition subtraction step, and 75 minus 48 is going to be 27. Next, on the back side, A wit group measured the length of their fingernails. The measurements are listed in the table. Use the data in the table to create a line plot using 1/2 inches. Then answer the questions below. So if we're using 1/2 inches, I want to take my line plot and it goes from 1 to 2 as a whole. I need to break it in half. And so I know this would be 1 and 1/2. Now I want to label my line plot with X's. I'm going to plot the data with X's. So I have 1 and 1/2. 1 and 1/2 again would stack. 1, 1 and 1/2. 1, 2, 1 and 1/2. 2 halves is the same thing as 1 whole. 1 and 1/2. 1 and 1/2. 2, and 1 and 1/2. So we can see that 1 and 1/2 has quite a few X's above it. 1 ended up with 3 X's above it. 1 and 1/2 ended up with 7 X's above it. And 2 ended up with 2 X's above it. What is the most frequent fingernail length? 1 and 1/2, because it had the most X's. It appeared in our data set the most often. What is the shortest fingernail length? 1. 1 inch is shorter than 1 and 1/2 or 2. And what is the longest fingernail length? In this case, it would be 2. 2 is our longest length. Rounding. Round 462 and 519 thousandths to the nearest hundred. So if I'm rounding to the nearest hundred, I'm going to go all the way to the hundreds place. And I'm going to say my number is built from 4 hundreds, which is equal to 400. If I add on one more hundred, I would have 5 hundreds in my number. And I know in standard form, I can write that as 500. The midpoint, the number that lies right between 400 and 500, would be 450. Now I want to plot my number, 462 and 519 thousandths, on the number line. And so I know that's going to be about here. And now we can determine if it rounds up or rounds down. When our number is at or above the midpoint, it's going to round up, such as in this case. If it were to lie below the midpoint, it would round down. So we're going to say it rounds to 500. To the nearest ones. So in this case, I'm going to go all the way to my ones place. And so my number is built out of 462 ones. And we know that's 462. And if I had one more 1, we would have 463 ones. In standard form, just written as 463. The number that lies right between 462 and 463 would be 462 and 5/10. We'll call that the midpoint. Now, to place our number on the number line, we know it's right above that, 462 and 519 thousandths. And since it is above the midpoint, it's going to round up to 463. Now we're rounding to the nearest tenths. So we're going to start with the greatest unit and go all the way to our tenths place. And so my number is made out of 462 and 5/10, which we call 4,625 tenths. And in standard form, that's written as 462 and 5/10. If I were to add on one more tenth to 4,625 tenths, I would have 4,626 tenths. In standard form, that is 462 and 6/10. The number that lies right between those two is always what's at the bottom of my number line. And 5 of the next unit, so that would be 5/100ths. And so now, in standard form, we would write that as, I'm going to write it right out here, it would be 462 and 55/100ths. Next, I'm going to place my number on the number line. The number actually would be right below the midpoint this time. 462 and 519 thousandths. And since it lies below the number line, it's going to round down. So we will say it rounds to 462 and 5 tenths.